But before you talk about functions, you have to talk about relations. Relations are any set of ordered pairs. Any set of ordered pairs. What that means is, okay, so these little brackets right here that I can't really draw are denote sets. A set of ordered pairs, so it's a pair of numbers or letters or words that go in order. So the most common one we use here is our X and Y, like graphing. X comes first, Y comes second. So that is in order because X always comes first, Y comes second. So you have 2, 3, 4, 5, 6, -8, -10, 15. So here is a set of 4 points. They are ordered because my X comes first, my Y comes second. So that is an example of a relation. I said a second ago that it doesn't have to always be numbers. So you could do words, as in, but it's just an ordered set. It could be numbers. So here you have a baseball team and then run scored. Okay, so the baseball team comes first and the run scored comes second. So it doesn't matter. It doesn't always have to be numbers. It can be words too. All right. So the next thing, the domain. The domain of these numbers, or the domain of these sets, are the first element. The domain is the first element. Okay, so if I looked at the domain of this one right here, the domain of this one would be all the first ones. So it would be 2, 4, 6, -10. 2, 4, 6. So the domain is the first one. The domain on this one would be the Royals and the Mets. The range is the second element. So the range is the second one. So this one would be what? 3, 5, -8, 14. And the range on this one would be 7 and 2. So domain is the first one and range is the second one. Like I said, the most common thing that we use in math is the X and Y, the graphing here. So a lot of times the domain deals with your X's because X comes first, and the range deals with your Y's because Y's come second. But it really means that the domain is your first one, range is your second one. So what a function is, let me get their definition because I think I like their definition. So a function, so a relation is any set of ordered pairs. A function has to have a specific set to it. It says for every X value, so for every number in the domain, there is exactly one Y value. Exactly one Y value, which is way harder than it looks like. If I go back to this red one, the very first one, I asked you what number 2 goes with, you would say 3. If I asked you what number 4 goes with, you would say 5. If I asked you what number 6 goes with, you'd say -8. If I asked you what number -10 goes with, you'd say 14. So every single one of those X values that I asked goes with only one Y value. So that one is a function. Okay, but if I had a relation that looked like this, and I asked you what does -3 go with? What numbers does -3 go with? -3 goes with 8, and -3 goes with 6. So since -3 goes with 2 different numbers, this one is not a function. Okay. So really what you're looking for is the repeats here in the domain. If it repeats, I've also seen like this visual aid drawn, which I kind of like. You don't want to have to draw it out every time. But. So in this one, my domain is 2 and -3. And my range is 3, 8, and 6. So here 2 goes with 3, -3 goes with 8, and 3 goes with 6. So you can see that -3 goes with 8 and 6. It cannot go with two different numbers. It can only go with one number. Trick one on this one would be this one right here. Is this one a function? Does every x value go along with exactly one y value? If I asked you what 3 goes with, what would you say? 1. If I asked you what 8 goes with, what would you say? 1. If I asked you what 9 goes with, what would you say? So then they all just go to one value? Okay, that's the trick one there, because if you look at the picture, though, those all only go with one number. So 3 goes with 1, 8 goes with 1, and 9 goes to -3. So all of these only go to one number. So that one is a function. So really what you're looking for here, when it's not a function, you'll see the same number in the domain twice. So you see -3 and then -3. Let's go look at a couple. So here, that's just finding the domain and the range. Domain's the first number, range is the second number. So determine if this relation is a function. So you look at the first number, 7, 5, 9, and 4. They're all different. Okay, so I know 7 goes to -9, 5 goes to -7, 9 goes to 1, 4 goes to 0. So this one is a function, yes. All right, but this one, if I asked you what -8 goes with, what would you say? Since -8 goes to more than one numbers, this is not a function. So since there's multiple numbers that are the same in the domain, it is not a function. All right, so here, I'm going to talk about that first. Kind of tells you why. If I looked at these 2 points right here, let's draw it out. If I looked at these 2 points right here, and I was labeling these, so this one would be what, 2, 3, this one would be -2, 2, this one would be what, -1, -1, and this one would be -1, -3. So is that a function? Why is that not a function? Because these two right here make it not a function, right? Okay, so what this is called, when you have a graph, instead of labeling all those out, you can use what they call the vertical line test. The vertical line test says if I can draw a vertical line through my graph and it hits the 2 points, if it hits more than once, it is not a function. So since this hits right here and it hits right here, this makes it not a function. So that actually saves me some time instead of having to write all those out. All right, so like this one, if I draw, is there anywhere I could draw a vertical line that would hit it twice? No, right? If I do a vertical line here, it only hit it once. So that one is a function because it only hits it once. All right, so what if you get in a graph like this? If I draw a vertical line here, will it hit it twice? Yes, so that one is not a function. If I draw it here, no, not that one, this one. If I draw a vertical line here, will it hit it? Will it hit it twice? No, it won't. Everywhere I draw a vertical line, it'll only hit it once. So it is a function. So if it hits it more than once, it is not a function. All right, so these are asking. I don't like these questions either. This is this makes a line, right? Your y-intercept's -5, your slope is 3. So they should look something like this right here. So is it going to be a function? If I drew a line through that, would it hit it twice? No, so this one should be a function, yes. This is a horizontal line. So if I have a horizontal line, if I draw a vertical line through it, will it hit it twice? Is there any way that could happen? No. So it is a function. What about this one, though? This one is a vertical line. So that one, it will hit it twice. Because if I drew it, I draw it right on top of each other, so it hit it a bunch. So this one is not a function. All right. This right here is called function notation, and it says f of x equals 2x plus 4. So what this means is if I put a number in for x, I'm going to multiply it by 2, and I'm going to add 4 to it. So every number that I put in for x, I multiply by 2 and add 4 to it. So that's the process of the function. So really, when you see something like this, a 5, negative 5, all I did here in the parentheses was I replaced the x with the negative 5. So that's what I do over here is I just replace the x with the negative 5. So when you see a number inside the parentheses in this function notation, all you're doing is plugging it in. And you get negative 10 plus 4 is negative 6. So this says when I plug in a negative 5, I get out a negative 6. So that actually means my domain is negative 5 and my range is negative 6. So when I plug in a negative 5, I plug out, I get out a negative 6. So here you just plug in 0, and then here you just plug in a 3. So you plug those numbers in. Well, it says f negative 5, so you just put negative 6 right there. Really, this is just a different notation. But when you have a number inside the parentheses like this, all you're doing is plugging it into the x. Plugging it into the x. Plugging those into the x. H of x is still, they usually use f of x or g of x. Sometimes they use h of x. But again, the same idea. The number inside the parentheses, all I'm doing is plugging it into the x. So this is what I was talking about, writing an ordered pair solution. This would be like negative 7, 2. That would be your x. This would be your y. I can't believe the answers. Here, graphing these is the same idea as normal. Yeah, this is like y equals mx plus b. It's just a different notation. Okay? It's just a different way of writing it. So it's still y equals mx plus b. Just think of replacing the y with f of x. It's still the same idea. That's your slope and that's your y-intercept. So same thing that you've been doing.
Like a
21.
Yeah. So at the top, it looks like its f is negative 5. But it's really
X is negative 5, right? Because inside the parentheses here, I have an x. So inside the parentheses here, I have negative 5. So the negative 5 is replacing. So whatever's inside the parentheses, you're plugging into the x.
I mean, how is f negative 5 and 0?
That's separate problems.
You wrote it as f equals.
Like what did we get for that one?
5. That, yeah,
We had negative 6 for that one. So now the next problem says f is 0. So now you're just plugging in at 0.
It's a 3-part problem.
Yeah, it's a 3-part problem. So now you plug in a 0 for x. So 0 times 2 is 0 plus 4 is 4. So that's just making me plug in multiple times. All right, if you got your computer up, you may jump over to these real quick because these are college algebra type problems. But there's a couple in here. All right, define the domain and the range. The domain, I said, deals with your x's. The domain is your x's and the range is your y's, right? So here, the domain, your x's, your x-axis goes left to right. Right, your x-axis goes left and right. So the domain of this graph is all the numbers that it could possibly be. So how far left does this one go? Yes, it goes forever to the left, right? So, but I'm going towards the negative numbers. So I'm going to say that it goes forever to negative infinity. Okay? Because I want to separate which way this one goes forever to the left. So it's going towards negative numbers, it's going towards negative infinity. How far right does it go? It goes to positive infinity. Right? So it goes all the way to positive infinity. So my domain of this graph is negative infinity to positive infinity. So the domain talks about how far left and how far right. The range, that's left and right. The range is your y, so it deals with up and down. I'm gonna start with down because you want the smallest number first. So how far, what's the lowest point of this graph?
You think that's one.
Yeah, it should be 1, right? So 2 right here, so that would be, so 1 is the lowest point of this graph. How far high does it go? This is gonna keep going up and up and up and up forever, so it goes to infinity. So the lowest point is 1, the highest point is infinity. So my range, the lowest point is 1, and the highest point is infinity. Now, why did I use a bracket here? Because remember, the bracket means equal to, so it does equal 1, and it goes forever up. So the range is talking about how far left and right it goes. The range, or the domain is talking about how far left and right it goes. The range is talking about how far up and down it goes. Another one of those. I think there's only 2 of those in there. You do a bunch of that in college algebra. This one's, how far left does this one go? It's gonna keep going forever and ever, ever to the left, right? And then how far right does it go? It goes down and keep going to the right. So it's negative infinity to positive infinity. What about how far down does it go? Negative infinity, how far up does it go? Positive infinity. So both the domain and range in those is negative infinity to positive infinity. We're not moving very quick today, are we? Those sections are kind of long.